Hello, everyone, and good day. My name is James Mancini, and I'm one of the founders of Netreo. During the presentation, if you have any questions, please enter them into the question section of the GoToWebinar interface, and we'll be sure to answer them at the end. Great, let's get started. So we're not going to sugarcoat it. Network management is a drag. The most common pain points we hear customers talking about are a lack of a single view into all of IT, over-alerting, and the admin overhead required to keep the whole thing working. But today, we're going to talk about how to alleviate what is usually the most painful of these, the problems and fatigue caused by over-alerting and drowning your engineers and techs in a sea of hard-to-understand data, what we call the data deluge. So some of the most common issues we see in this area are things I'm sure you can all relate to. Your inbox, phone, and chat apps are all exploding with notifications, sometimes hundreds or more a day, and at that rate, no one can possibly hope to keep up with them, much less make progress on solving any underlying issues. Even organizations with complex monitoring systems in place are often stuck in firefighting mode because they're reacting to alarms as they occur, but never really getting on top of the causes. And in some cases, they're even missing real issues, sometimes because of a failure in the monitoring system configuration, and sometimes because the alert was just lost in the avalanche of noise coming from the system. So what's causing the alert flood? Generally, it comes down to a few key points. The lack of a defined notification plan is a big one, and we'll talk today about how to best solve that issue. It leads directly into the next, which is over-configuring monitoring and alerts. Too many alerts is just as bad or worse than too few in many cases. We also see cases where customers just plug in a monitoring system and switch everything on at once, figuring it's best to see everything that's happening. But generally, this ends up with so much noise. They get so buried in notifications and false alarms that they rarely get the insight that they're looking for. So our philosophy is that alerts should be restricted to only truly actionable items, things that are going to drive a real-time response. One of the most common issues with alert management we see is organizations that are stuck in this firefighting mode. They spend so much time putting out fires that it comes at the expense of dealing with real business requirements and moving the organization forward. Even larger organizations with well-defined roles and a robust monitoring strategy can fall into this trap, especially if they're only getting reactive alarms. A smoke detector is important, but once it's going off and the building is burning, you aren't going to have time to plan out the sprinkler system. Another common cause we often see is little to no automation in use, which can drive stale configurations and slow response times and long mean times to repair. Many systems also rely on static alerts, which don't adapt to changing conditions. These are going to miss important problems as they're emerging until there's already a fire to put out. Lastly, a big driver of this problem is that many systems lack good reporting and long-term visibility. Some of the most popular network management tools only save a week's worth of data, for example, and that's never going to get you the detailed reporting and trend data that's going to help you make your organization truly proactive and be able to focus on prevention rather than rushing from one burning building to another. Often the reason for missing these issues as they happen is a lack of a monitoring policy that defines what should be watched and how. It can also be driven by a failure to connect the development and production teams well, where the production engineering support teams aren't even sure what the critical paths of a new application are when it's rolled out. This inevitably leads to missed configuration steps or gaps in the provisioning process where new systems aren't being onboarded to the monitoring system correctly. And that's a process that should really be fully automated rather than manual anyway. So how do we get all this under control? The first step is to create a monitoring policy if you don't have one already. This will lay the groundwork for what should be monitored and how to monitor it. And this is important because often technical teams will start with a monitor everything approach like we've talked about, and this will inevitably lead to millions of unread alert messages for things that don't trigger a response. It'll overwhelm the team in useless noise and completely swamp the help desk or the ticketing system or the NOC with all of these false alarms that they then have to try to manually sort through to figure out what's going on. The plan should also clearly define an action and escalation contact, who to get contacted for a particular type of problem, what are the time frames for that contact, what methods of communication should be used. You should also make sure to build in a timeline to revisit this plan regularly. This is going to depend somewhat on how fast your environment is evolving. Some organizations might be able to do this annually or semi-annually, but the rapid pace of change in a lot of industries might mean that you need quarterly or even monthly revisions to keep up with what's going on in the environment. So let's look at some easy ways to accomplish that. One of the first steps is to define your priority level so you can have a clear model for when to escalate a particular issue and what defines a full-blown crisis from a minor problem. So here's a simplified model we often use to help customers develop their own priority system in case you don't have a well-defined way to do that yet. It starts with defining our impact metrics. In this case, how severely are the users impacted by a problem, and then plot that against how many users are affected by the problem. In other words, are the users unable to work entirely? Is the factory stopped? Are orders not going out? Or is it more of a minor inconvenience, like a routine task takes a few seconds longer to complete, or it's creating delays in internal reports? Once you have a picture of what's important here, it's easy to divide this graph into zones by priority, which can then drive the action plan, like who gets notified for a priority 1 versus a priority 2, how quickly does a problem escalate when something isn't going right, or when a problem doesn't get resolved quickly enough, who to escalate to and how to escalate that can all be defined by priority level within the organization. One of the key points here is that if everything is critical, nothing is critical. We can't treat everything like a priority 1 issue, or we're going to end up with a problem where we can't filter out what's really not important versus what's critical and needs an immediate response. So if we can define an action plan that can be relied on for detailed instructions during a crisis, that's going to help us respond much more effectively. And at a minimum, this plan should define who should be notified during an incident, and exactly what methods should be used, both for the initial notifications and then define the timelines and methods for escalation as well. How long should an outage persist before someone in management is notified, for example? This will also depend heavily on the scope of the outage and the priority, so make sure you outline clearly exactly what's going to be communicated to them. Remember that badly worded notifications are counterproductive. It can cause people to panic and take incorrect actions. Also remember to factor in time of day and day of week. A lot of enterprises are 724 by 365 type operations, but many aren't, or at least not for all of the resources. When a system goes down after hours but isn't going to be needed till the next day, what is the defined process? When someone is available to work the problem. So a different response to an outage during off hours is a reasonable, appropriate in many cases, and the monitoring plan should reflect that. Lastly, don't forget to see what you can automate. Automating the initial response to incidents to do things like reboot servers, spin up new cloud resources, or restart services in a cluster can drastically reduce your time to repair, often before you even have to intervene manually. Notifications are important because during a mass outage, you need to be able to reliably communicate what is going on to all the different teams and stakeholders. Your monitoring plan should address exactly how you're going to get notifications to people, especially factoring the difficulties inherent in a mass outage. Email and SMS are usually the foundation that most notifications are based on, but those may be impacted during a crisis or simply saturated with alerts and notifications if we haven't fully talked about, or if we haven't implemented all the different ways we've talked about to minimize them. So we should consider alternative methods as well. For example, mobile app push notifications take a path that is entirely separate from email, and these can even be initiated from the cloud. So the state of your internal networks or systems won't necessarily affect it. You can also use API integration into team communication platforms like Slack or Spark or Bittrex or others to make sure that all the members of the team are aware of what's being done, when, and by whom. It also creates a kind of log so you can go back and see, okay, well, Bob restarted that server at 10:45 a.m. He posted it into the Slack channel, so we know that's when that happened. The notification system, the monitoring system itself can be posting notifications to the same channel so that you can get an idea of exactly when something happened, all in kind of one continuous feed. And that's really useful for communicating, especially with larger or distributed teams. But your plan should also leverage the existing operational systems that you have. So if you've got existing systems like notification managers, this can help to eliminate redundant alarm sources, and you can consolidate those incidents into a manageable number of alerts. So integrating with things like OpsGenie or PagerDuty for notifications can simplify on-call schedules and can provide a way to distribute alerts that isn't dependent on your internal mail infrastructure. Many organizations will also be using a ticketing or an ITSM type system like ServiceNow. You want to make sure your plan includes how those tools should be used during a crisis and how to integrate them with your monitoring and alerting systems. Some of our customers prefer to have monitoring send all of those alerts to the ticketing system and let the ticketing system sort and consolidate and then send notifications. Some prefer to have the monitoring system send the notifications directly so that then they can decide what's worthy of actually opening a trouble ticket on. Really depends on your organization, which is going to work best for you. So as a key part of the strategy, and in keeping with our own overall philosophy, we always recommend reserving active alerts for actionable items only. So the idea is if you're not going to react to a notification as soon as it comes in, you shouldn't be alerting on it. For example, if you're getting alerts when hard drives reach 90% utilization and then just ignoring them because it's not quite urgent yet, two things are going to happen. First, sooner or later, you're going to get a server failure because you forgot to circle back on that alert before the drive filled up. And second, you're conditioning yourself and your teams to ignore alerts, and someone someday will inevitably ignore the wrong one, and you're going to have a major problems on your hand. So instead, you can configure reports. So for example, every morning I can get a list of servers with the lowest free drive space, and I know if I deal with the top few entries on that list, I get to sleep through the night. A key success factor to making that work, though, is to automate those reports so nothing gets missed. You don't want to depend on some poor soul to take time every week to run and send the report, that's a task that's just sure to get skipped when they're up to their necks in alligators or fighting fires. So let's look at a few examples of alerts to define what is really actionable. So let's say we get a high CPU alarm. Is that an actionable alert? Well, it might be if the CPU has been stuck there for a while. So OmniCenter allows you to set a delay for these types of alerts so they don't generate an alarm until it's been over that threshold for some length of time. As an example, a SQL server might peg the CPU 20 times a day, and that's probably normal, and I don't want that alarm. But if it's been pegged for 30 minutes continuously, I probably have a job I need to go kill. So I need to be able to set those thresholds on a very granular level. If a switch port goes down, is that actionable? Well, it is if it's plugged into something important. So this is generally a yes, and this might be a good candidate for an immediate alarm. But what if it's part of a port channel or it's just one server in a large cluster? That might warrant a different priority response or a different method of notification that doesn't require a drop everything and fix this response. What about if the public website goes down? Well, that's generally going to be a big yes, but you might want to make sure it's down from outside the environment as well as inside so you can properly orchestrate the response. And it's important to know if it's just the web page returning an error or the backend going down or a server failure or something else. So using things like application checks launched from multiple remote locations and multiple levels of service checking can help you assess the issue before you even have to start troubleshooting it. A great way to get control of the amount of alerts being sent is to integrate automation. So automation comes in a few flavors, and the first place to look at is automating the response to the alerts so we can eliminate the need to send a notification at all in many cases. You can link to vendor APIs like webhooks, for example, so your monitoring system can do things like restart ports, retest applications, or even dump real-time diagnostics in response to an issue. This can be a huge time saver for troubleshooting a problem because I have a running process list that got dumped off the server the moment the CPU spiked. You can also do things like execute those commands manually through the operator intervention. So for example, if I don't trust automated restarts of the server, but I want to have an operator be able to just go into the monitoring system and click to the restart server button, I can do that very easily. And in OmniCenter, you can limit that access by user privilege level. So I can maybe only administrators can restart systems, but operators in my NOC can restart services. And I can have that kind of as a push button control that they can easily execute from their monitoring system they're already looking at. One important thing to keep in mind, though, is that if you're using any kind of automated response, maintenance windows become critical. Otherwise, a scheduled software upgrade might not go as you expect as the monitoring system starts doing things in the background. Nothing's more frustrating than shutting the application down for a planned upgrade and then having the server suddenly reboot on you. One of the best ways to reduce the number of alerts coming in is to leverage the tools to take advantage of things like automatic alert suppression and root cause detection. So by configuring a topology into the tools or letting the tools discover the topology and dependencies, the tool can determine that the reason, for example, that all the remote devices at a particular location suddenly went unreachable is that a failure on the WAN router happened. So instead of getting separate notifications for every remote device, like every switch, every server, every application, every wireless access point that's at that location, I can instead get a single alert that says the problem is the WAN router went down and everything behind that is now unreachable. So consolidating that into a single notification is probably the single biggest thing you can do to reducing the volume of alerts. We also build in a lot of tools to help you optimize those alerts. So you can identify what we like to call the noisy birds. So these are the few configured alerts that are responsible for a disproportionate amount of the alarms, or those where an adjustment to the sensitivity might be required. You can also use what we call a template baseline report. The template baseline report allows you to see exactly which alerts are being generated by configuration templates and make changes to them directly that can then be automatically rolled out to all the devices where that template is applied. So if I've got a setting in the template that's generating the majority of my alerts for a particular type of devices, I can quickly see that using the template baseline report and drill directly in on what needs to be adjusted to make sure that those alarms go away. You can also use things like the notification summary report. This allows you to take and look at all the notifications that OmniCenter has sent and summarize them by device or by service check or by threshold type so that you can see exactly what alarms are going out and why, and get a count of how many alarms went out from a particular time frame for each device or from each type of service check or threshold alarm. Again, makes it very easy to zero in on the ones that are causing most of the noise. One of the best practice recommendations we often give customers is to use distribution lists instead of individual emails for email alerts and automated reports. There's a few good reasons to do this, but one of the key ones is to better keep in sync with personnel changes. So there have been more than a few incidents where a problem was detected by the monitoring system, but the alert went out to an abandoned or an invalid mailbox, and this caused a significant delay in detecting and acting on the problem. It also allows you to create an easy historical archive of automated reports and share them in a central location. So if you need to go back to the weekly performance reports from 2 years ago in September, they're easy to find and locate, even if the detailed data has been archived by now. Let's talk about another way to automate the monitoring process. And that's going to be to automate the monitoring system configuration. So it's key to make sure that the centralized visibility can stay up to date even while your environment is constantly changing. And one of the easiest ways to do that is to link the provisioning process directly into the monitoring so you can automatically discover resources via API, or as you deploy new resources, for example, in Puppet, it can push configurations into OmniCenter so that they can automatically start to be monitored. This allows you to drive that configuration forward using our auto configuration rules, which we'll talk about in a minute, that then allow you to drive things like category, site, strategic groups, templates that control every aspect of the monitoring configuration with minimal manual intervention. You can even link your deployments with automatic maintenance windows via the API. So if we're spending less time putting new systems into monitoring or taking them out of monitoring, it means you've got more time to focus on your important tasks and move the business forward. You should also make sure you've linked the monitoring system into cloud resources, so those can automatically be discovered and added into monitoring as those are deployed as well. Now, I mentioned the auto configuration rules, and OmniCenter uses this auto configuration system to automate the configuration based on a number of different criteria. So it comes with a set of rules to kind of start you out, and you can easily customize those rules or create new rules to fit the environment. These rules allow you to set configuration attributes like category, site, application groups based on any device criteria, including things like which processes are running, what ports are open, what the device is named, or SNMP values. And this makes sure that there's no manual step in the configuration and provisioning process, so you can ensure that devices end up in the correct reports and that they always get the right settings applied. These will automatically be applied to devices as they're discovered. So if OmniCenter learns them via scanning or via API calls to vCenter or to a cloud system, or they're pushed in via an API link to one of your existing provisioning systems, they'll automatically apply all these rules to these systems, but you can also reapply these rules as desired. So if you want to make sure everything stays configured exactly the way the rules say to, you can enforce that. Using those criteria that we just set with the auto config engine, OmniCenter then dynamically applies all of the relevant templates to the devices. Multiple templates can be automatically applied, and the settings from each of them will intelligently roll down onto the devices. So this way, a new SQL server coming online would not only get the basic Windows server settings that we've defined, but also would get any SQL specific application checks and settings that we've set. It would allow us to align that monitoring plan with the templates to make sure all the right priorities are set and the timings and the escalations, so that we can predefine all of the correct authentication, escalation, any automated actions that we want. And the system is designed to be flexible enough to really meet the needs of a complex global enterprise, but still be simple enough for a small IT department to use without a lot of training or dedicated personnel. And one of the key aspects of reducing false alarms and getting out of the firefighting mode is to use anomaly detection. So detecting unusual behavior instead of just relying on static alarm settings is a key way to get proactive with the monitoring and really find the issues before they start impacting users. So with OmniCenter, you can use anomaly detection to find changes in application behavior, and it can be applied almost anywhere. Things like CPU, memory use, running processes, even log messages. So if your application suddenly goes from 10 login failures an hour to 1,000, maybe that last software deployment didn't go quite as smoothly as it looked like, and now I at least know exactly where to start troubleshooting. OmniCenter will automatically generate a baseline behavior model using the large volume of historical data that we retain, and it will automatically adapt that baseline as the environment changes and evolves. You can detect anomalies based on changes in behavior looking at time of day of week, or even hour by hour. And this allows you to find unexpected impacts, like a software change that caused unusual behavior in a CPU on a backend server. So as an example, one customer of ours discovered an issue where at 10 a.m. on a Wednesday, normally the database server was running at 50 to 60%, but suddenly one day it was running at 15%. So they dug in and looked, and it turned out that a software change to the user interface of their website broke the CSS on a form deep within their application where the front end team didn't notice it, and the customers weren't able to complete the orders properly. Now, that sort of anomaly is the kind of unusual behavior that would never trigger a static threshold, but in this case, it was revealed by the anomaly detection, and they found the problem long before they noticed a drop in orders and all the customer complaints that would have resulted. So a key point of having a successful monitoring plan is to make sure it's being used and to stay on top of the monitoring system process. So make sure your techs and engineers are acknowledging problems as they're dealt with. Don't let the monitoring screens get flooded with alerts. A monitoring screen that's flooded with alerts makes it very easy to miss a new critical alert. Alerts need to be acted on and acknowledged or corrected as soon as possible. It's not acceptable to let alerts sit in the queue until the support team's regular working hours. If the condition is acceptable during off hours, then the alert should only be generated when it is not acceptable and when someone is available to work on the problem. Alerts that don't get addressed within a specific time frame need to get escalated. Also, using maintenance windows for your planned outages will not only help reduce the volume of alerts, it will also normalize things like uptime reports. So systems with no unplanned outages in a given month will show 100% without having to manually adjust the reports or write explanations to roll them up to senior management. Finally, don't ignore alerts. Ignoring alerts is a sure way of getting into trouble. At some point, a mistake is going to be made. Someone's going to ignore the wrong alert. So avoid the problem altogether by making sure non-actionable alerts are not even seen. You can still report after the fact on adverse or unusual conditions for proactive investigations. Now, I'd like to take just a moment to talk about who we are for those of you who haven't worked with us before. Netreo has been around 19 years and profitable since year one, providing easy to use and comprehensive network management systems for private and public enterprises. We've won Monitoring Product of the Year from Network Computing UK 3 years running and are nominated again this year. And we made the Inc. list of fastest growing companies for the last 2 years as well. Last year, after 18 successful years of being internally funded, we did a private equity transaction to gain additional working capital and resources, as well as access to some very experienced business experts, allowing us to grow even faster. And our track record in enterprise business speaks for itself, with customers like Wells Fargo, Aon, Partners Healthcare, SpaceX, and many others, with whom we maintain more than 95% customer retention since day one. Now I'm going to go ahead and take a moment here to answer any questions that have come up during the webinar. If you haven't yet submitted questions in the webinar interface, please go ahead and do so. And I'm going to go ahead and also kick off a poll. So if you need to get some additional help from us, you can fill out that poll and we'll definitely contact and follow up. So the first question is, how much historical data do you keep for anomaly detection and reporting? So by default, OmniCenter keeps the last 3 years of data. It does roll it up over time, but it rolls it up into a maximum of 4-hour averages. So you still have, time of day shift visible as far back as 3 years. And we keep the most granular data for a minimum of 100 days. So that lets you get into the most detailed data for things like your anomaly detection, and going in to run quarterly reports is always the highest possible resolution. Anomaly detection itself builds a baseline over the last 8 cycles, and those cycles default to time of day and day of week. So I can look at this time of day on the last 8 Wednesdays and build the baseline based on that to look for unusual behavior. And then you can adjust how sensitive that is to things that deviate from that baseline. So you can set it to very sensitive, a small deviation will trigger an alarm, or not very sensitive and it takes a larger deviation to trigger that alarm. You can adjust those, so instead of looking at weekly, you can look at daily or even hourly if that makes more sense for the particular stat that you're looking at. The next question is, how granular is data collected by OmniCenter? And this question is a little bit complicated because it varies depending on the type of data that we're collecting. For example, bandwidth on high-speed interfaces is collected at 1-minute intervals. On lower-speed interfaces, it might be collected at 5-minute intervals. Things like process utilization is collected at 5-minute intervals. And other types of data, like, for example, NetFlow data or syslog data, are collected in real time as the devices are sending them to OmniCenter, so those are available immediately. But we store all of those in our internal onboard database, so it's completely self-contained, and there's no external storage requirements to meet that 3 years of historical reporting as well. Okay, well, hopefully we've shown you a few things today that you can use to improve your response from problems in your environment, as well as to reduce that flood of alerts coming into your phone and your pager, and hopefully get a little bit more sleep. If you have any other questions, please feel free to reach out to us at info@netreo.com, and we'll get back to you right away. Thanks very much, and have a great rest of your day.